anymore. Yeah.
Now it has happened. All right. So Kubernetes SIG, or sorry, Cassandra on Kubernetes SIG, February 25th. Hey, Eric. All right. So there's a lot of stuff going on, and we figure let's talk about releases. Let's talk a little bit about roadmap and things like that. Lots of news to share today, so I figure we'd start taking a bite out of it. But I'd also like to promote some discussion here and get feedback on some of those items. So first and foremost, we are cutting a release of CAS Operator today. This includes the changes donated by Orange from CASCOP. Specific One of the specific features being the node affinity labels. So previously, when you specified a rack, there's a zone parameter. You put in your AZ name, and it would line up with a particular label on nodes that's fairly common in Kubernetes. Those labels have been in flux since we started on this project. I guess it's been over a year now. Uh, so it's nice to see the ability to support any free-form combination of labels. And in non-cloud environments, that's nice because if you use any other labeling mechanism, this can be really helpful. Like, for example, I worked with a customer where they had data centers and then rooms within the data centers and then racks within the rooms within the data centers. And this new functionality allows you to just use whatever you want there. You can even manually label specific nodes as being for Cassandra and having specific racks and target those instead of just having a single field. That's a huge win. Something I've been talking about for a while now too. So it's nice to see that come in. So big thank you to Cyril and Orange. And maybe they'll be joining here in a little bit, maybe not. That's okay. So 1.6.0 is that release. It's also worth noting that there is it looks like the pieces are coming together for a release in the Cassandra project that includes, if I'm not mistaken, John, please correct me, the 1.6.0 release for the operator. Final testing is going through with that right now just to make sure everything's in a good spot. But this is actually the 1.0 release, so a big milestone there. We've consolidated from multiple charts into a single chart for an installation. Almost everything is namespace scoped at this point. Stargate is there as a coordination layer. There's some interesting pieces to that we're going to be exploring with content here in the coming weeks. Specifically, there's a lot of conversation around Stargate for HTTP APIs, but there's a separate conversation around Stargate for native protocol. So you can actually connect with your Cassandra driver, talk to that, and it takes all those coordinator tasks away from the nodes that actually store your data, which is kind of fascinating. So that's another big feature. We have authentication enabled, non-root images. There's a whole big list. I expect there will be a blog post out about that tomorrow too, which leads me to another point. There will be a blog on cassandra.io starting with the release of those, with that release as well. So really big news there. I'm really excited to see it happen. Any questions about that or curiosity?
Yeah, just a couple of questions. So CAS Operator 1.0 is getting pushed out. Now, when you said Cassandra, the new release is coming, which version of CAS Operator is going into that right now? The same 1.0?
So CAS Operator version is 1.6.0.
That's what I heard before. Okay, thanks for correcting. Yeah, okay.
Cassandra is 1.0 and it includes CAS Operator 1.6.
That's what I misheard. Thank you. Yeah. And then in terms of like the biggest feature you would say is the node affinity fix, basically not being limited to cloud AZs, but being able to have your own naming conventions that get used for the rack. Is that correct?
Yeah, when you define your topology, you're a lot more freeform in how you can make that definition. One of the things I've been a fan of or I've been curious about is in a multi-tenant cluster where you're going to have your app servers as well, Kubernetes cluster to be clear. When you have app servers as well as Cassandra instances running, how do you pin those to various locations? And we've had some tools for that. This lets you be a lot more explicit and freeform in those definitions. And I think that's where the power is. I don't have to run separate Kubernetes clusters. I can tag a bunch of nodes as being Cassandra nodes, and a bunch of other nodes as being compute nodes or app server nodes, and target those with my resources.
Great.
Another big feature also from Serial is the ability to define additional PVCs. So you have, and that's, so, Cas operator creates a PVC for varlob Cassandra. And with that change, you can now, if you want to have a separate PVC for your commit log, using CDC, or for anything. So that's a really nice enhancement. And I've opened up tickets in Cassandra to leverage that functionality. It won't be in 1.0, but post 1.0 to leverage it in Cassandra.
That's a good catch, though, John. I reviewed the PR earlier today, and I was like, I know I'm missing something big right now. It's like additional config or something like that. Thank you. That's what I'm trying to say. Great. I'm looking at the list of things that are landing in that 1.0. There's a move to Kubernetes stack for setting up the monitoring stack, leveraging native Kubernetes ingress resources for anything that speaks HTTP, because that's what native Kubernetes ingress speaks. This is the big item. So we also started making dedicated charts for sub projects. So for the Reaper operator, Medusa operator, really excited to see that, because that lets you, if you aren't going all in with the Cassandra platform, you can still leverage those projects in your deployment. There are plenty of enterprises and users that will, they already have some of these pieces in place, or they just want to, I could see even deployments where you have your Reaper instance running on a Kubernetes cluster, even if you're keeping your actual Cassandra nodes on-prem or in virtual machines. So it's nice to have that be an option to be leveraged.
Is that in the coming release 1.0, or is that something in the future? The dedicated subcharts?
For not everything is in a dedicated subchart, but the operators are already in dedicated subcharts. You can install those specifically today.
Okay, great.
Great question. So we're talking a lot about today and the release, which is currently scheduled for tomorrow. But I think it's worth us talking about the future direction of Cassandra on Kubernetes and some of these projects, and what we're trying to see happen here over a number of milestones, or I don't want to say quarters, because that doesn't seem right. I call them milestones because I don't want to tack them specifically down to particular dates on the calendar, but just a general idea of where we want to be and what we can do to enable people that want to be running on Kubernetes. So I think that's worth kind of exploring, and we have some users here that I think it'd be valuable to get some feedback on.
One of the things I've been doing with the client is getting them socialized to the CAS operator, as they cannot, they're very regulated, right? So they're either okay with using something that's already in their whitelist from a cloud native, or they will use whatever is possible on Kubernetes. And so one of the things that came up is like, it's great that with Cassandra, it's like super easy to, pull it down, run it, have something up and running, and everything that's happening on Cassandra is great. But I know, and I also know that, DataStax is going to put information about Cassandra and Kubernetes as part of the new certification. But basically there's the ask for, is there a 3, 4, 5, 1 to 5 part tutorial of how to get really good with this? Not really good with this. Like, how on the Kubernetes.io site, there's like this 4 or 5 lessons you just go through, and it's on Katacoda, and you can just like play with it, or you can go to like playwithkates.com and do stuff. That's what people have been asking for. And I know that Cassandra is complete, but is there something ready to go from the CAS operator maybe John, you created something in the past or it's already on a blog post somewhere that we can, circulate, or maybe even like rephrase and put on the Cassandra blog.
So there's something that's being worked on right now. I'm making sure that it's out there. There are a number of Katacoda scenarios for Kubernetes being developed. Sorry, specifically Cassandra on Kubernetes that talks about it. It doesn't just look at Cassandra, but there's also running Cas operator. Like the logical progression of this is, let's get you started with just the bare basics. You have a Kubernetes cluster, you have Cas operator. Let's talk about what that means. And then let's start layering in some of the other pieces that you would want to see in a production-like environment, right? And show you not just how to use the automation, but walking you through all the individual components.
Yeah.
And then by the time you get to using the automation, you understand what's going on underneath, what all the machinery is. So if something does happen, you're not just like, my automation is broken. It's like, my automation is broken, but maybe there's an issue here within just the operator. Let me go look at that custom resource. I know that custom resource exists, right? And how to interact with it. I know what pods and services I should be seeing, not just the native protocol connection isn't being established. So let me take a look and see what's, if that's a link I can send you this second. All right. And Rahul, maybe I can send that, I can sync up and send that out after our call.
Yeah, that's cool. I'll just, I'll make a reminder to follow up with you.
I found the link. It is in chat right now. It's posted out on DataStax Dev, but it goes into, it's using Katacoda as well. So
okay, cool.
Yeah, check that out. And there are a number of events too. There's actually a workshop happening next week on Cassandra on Kubernetes. Make sure there's a link to that.
I think there's more stuff on it now since the last time I did look at it, but this is great. Great start. Thanks.
Oh yeah, it's continually being built out. So I would expect to see more scenarios coming online over time.
Also curious, is Cassandra going to try to, position itself? I mean, I think probably a goal, but like to join the cloud native foundation as like a project in the CNCF.
I can't commit to that happening. I can say that we are having conversations with foundations. I think that's a logical step for this kind of project. And Patrick unmuted, so I'm certain he has something to say about this.
Yeah, it's like, hey, Rahul. No, we of course, Linux Foundation CNCF is very interested in this, but it's like anything else. It's like we need to get it to some sort of a place, like a good place for donation into foundation. Yes, the answer is yes. In the details, who knows? But it'll probably start with building out the right competencies, like just like an incubating project.
Yeah.
I've done a lot of incubating projects before. There's things you need to do. You need to make sure that you have all the bells and whistles involved. Like, do we have a steering committee? Do we have good participation from multiple groups that aren't just a single vendor? And, so we got some work to do there. I think, Rahul, you're going to say yes when I ask, but, when you're like, people that are in this call are like the type of people that we want to work with, but it's like, I'm involved, I'm engaged, but foundation is the only way for things like this to work.
Yep.
Bottom line.
Awesome. Thanks. I think this is some seed that Patrick had planted while what is the native data storage or data option for Kubernetes, and can Cassandra be that? And obviously Cas operator and Cassandra make it easier. What are some other thoughts that you all have to kind of get that into the people's mindset, I guess? to the point where like people just, it's a foregone conclusion, right? If you're going to set up a cluster for applications, you use Prometheus, you use Grafana, maybe use Cortex or whatever, right? Like, but you're going to be like, oh, but I need Cassandra for that. I need Cassandra to be a part of the general reference architecture if we're going to make a scalable app. And we're just thinking like out loud here, beyond Stargate, what can be like a killer reference app that people are just want to try to use, just to pull it down and play with it. And that's what I've seen as successful from some, at least say some projects, is that the Hello World project that people can use in their operations, like from day one, not having to go and make their own data model. I'm talking like ready to go, something to use, that can stick around in an organization for a long time,
Definitely. And it's interesting because there's a number of sample apps that are getting pulled together, and that would work without any issue with Cassandra. And that's something that we're very cognizant of. So I don't know if we're going to be talking about that too much with 1.0, but there are a number of sample apps in flight, or that have already been written, where it's just a matter of tweaking the connection location and spinning it up.
I think this is like one of those perfect things for contribution. It's like, well, I don't know a lot about, the internals of Kubernetes or the internals of Cassandra, but I deploy like SRE knowledge. I deploy applications on Kubernetes all the time. I love Cassandra. I'm going to try to put some work towards this. If there was, like, and this is because we're recording cattle call. if there was individuals out there that could say, here's a stack, like here's a typical deployment that I would put on Kubernetes that scales, and it's, everything from ingress to database, and, it deploys in a clean fashion so that you just say, Helm install or use kubectl and you can get it all set up with your deploy. That would be amazing. And Chris, we haven't talked about this, but I was actually thinking about this as an option, is putting this like on the Cassandra repo, like having a place where we have just examples, like you post your deployment.
Yeah, definitely. I think that's something that we really want to see happen. That's part of the community engagement, right? Is show us what you built, right? If you want to open source it, we'll happily put links out to your repo, feature it. I would love to do an interview with somebody who's done this type of deployment and wants to talk about their projects. I think it's fascinating, the decisions that are made, and whether that's the language being used, the framework, and why you chose that particular Kubernetes resource. I think those are all really crunchy topics. And yeah, I think there should be a call for anybody that wants to contribute in that way. I'd love to talk to you.
There's a good example, I think, on the Zero to Hero for Jupyter Lab. Like, it's really comprehensive. Like, here's how you get started with Kubernetes on Azure, on AWS. It's not like the most comprehensive getting started thing, but it's like it gets you started on Azure, gets you started on AWS or whatever. There's like 10 different clouds or on premise. And then it says, okay, now this is how you get started with Jupyter Lab, and this is how you customize it, right? So I know that Cassandra has much better documentation than Cass Operator right now, but that's something where I literally have sent that to 3 people in the last week, and I'm like, go learn this, because this is what we're going to be doing. We're going to be doing this for a project, and they're just going one by one, probably within 2-3 days. I don't necessarily think they're going to be ninjas at it, but they will have created a customized Jupyter Lab environment, because it's so cleanly written that an idiot can do it. It's like, and it's useful because people need this stuff. So the other,
you mean I can do it? Oh, I'm so excited.
I mean, I can do it, Patrick. If I can do it, anybody can do it.
So we've done something.
And whenever I hear idiot proof, I'm always like, hold my beer.
There's a couple PRs landing right now for the Cassandra documentation site to build out the getting started section. It's actually pretty fascinating. We start with the every user section, which is just like, make sure you talk to Kubernetes, right? Let's make sure you have nodes with enough resources. But then it goes through actually doing the install and verifying your deployment. Like, are the right pods up? Are they actually running? Are they still pending, right? Do you have the right services? Making sure everything's in a good spot. And then it goes into like a choose your own adventure kind of mode where you can say, I'm a developer. How the heck do I talk to this thing? You can say, I'm a SRE. How do I make sure that this thing is stable? How do I monitor it, right? And go to explore those interfaces and really give you a more cohesive experience, because previously it's just been, oh, hey, you're done. Like you run Helm install, good luck. And that's that's not very friendly. So I will, that's in review right now. Some of it's already been published. I highly recommend the getting started section because it's a lot more thorough. And then where that maybe isn't enough, there are the Katacoda scenarios where it's more guided with particular steps that you can try right there in your browser.
Yeah, I mean, I'm thinking like, so like a lot of the examples, I do the playwithkates.com test, right? Can I go on there, add 3 nodes and do it? And if I can do it, that means I can do it for real on a real, production or whatever in my cloud. The other thing I was thinking about is, I mean, the major killer application is Spark, or Kafka. And I know there's tons of operators and Helm charts for those kind of, that may be something that I can put somebody on our team on is, okay, get Cassandra up and then put Spark in there and, put Kafka in there and whatever, grab crap from Twitter, process it.
That's the thing that I think is super interesting about deploying on Kubernetes and having this kind of automation is you can say, okay, previously where I had to like spin up instances, run some automation to install Cassandra, wait for it to come up. Now it's just like, all right, Helm, do your thing while you're pulling images down. I'm going to go and find this other Helm chart for Spark. And you can focus on like the components and just that little bit of plumbing between them. Instead of, all right, I have to go deep on this one topic just to get this one piece set up. And now once that's up in a good spot, now I need to go really deep on this topic. And that's pretty powerful.
Yeah.
We want to be freeing of the tedium, right? So I think that's where things get fascinating. I do have a question for you, Raul, and some of the other people here. I'm curious about defaults, and specifically defaults for new user experience, right? So if you were to install if you were going into one of these scenarios, what do you think the topology looks like for a local developer installation, as well as let's talk about that a little bit. So just local developer installation. If I said, hey, if you do a Helm install, what do you think you should have at the end of that command? The shape of that.
I like to talk, but I'm going to wait for other people to talk first.
Okay. I think John's a little biased, but Madhavan, feel free to pipe in here.
Madhavan, you're muted if you're trying to speak.
Oops, yeah. I'm still trying to learn all this stuff in here, so I don't think I have a good solid default contribution here.
Fair enough. Mary, do you have anything that you want to?
Sorry, can you repeat the question? So
yeah, if you did a Helm install to install a Cassandra stack inside of your Kubernetes, so for your local machine, right? What do you expect that to look like when it's done? Like how many nodes should there be? Like what kind of traffic do you think it should support? Should we be talking about multiple gigs of heap or fairly small and tied down, but more nodes? What do you think that looks like?
I mean, so I'm pretty opinionated when it comes to this stuff. Actually, I probably wouldn't. if it was something that was going to be installed with Helm, I'd probably look the other way to begin with, but that's just me. So we actually do this. So at DreamWorks, we run, I don't know, 400, 500 database clusters on Kubernetes, a mix of Cassandra and Elasticsearch and Couchbase and everything, right? So what we generally end up with are very small clusters, and we want them that way. So we take the notion of, like a microservice, and we kind of adapted that to a database, and we came up with this notion of a microcluster. And so every microcluster or every microservice basically gets its own deployment of a small database, whatever its backend needs happen to be. So for things that need Cassandra, we'll just spin up a small, and the smallest we will go is generally 3 nodes, because we want the HA, right? So, and we'll split those across availability zones. So that's traditionally the smallest we'll go, and it's basically to the point for us anyway, where we never felt like there's very few cases where we actually need to scale out beyond 5, maybe 5 nodes is the max, maybe 7 nodes in like a really heavy used application. But because we have these micro clusters, basically each cluster contains just a small amount of data, and the load of that microservice itself is actually pretty low in comparison to sort of the holistic application, or the service at a whole. So we generally tune these things really light, a little bit of heap. Only recently are we starting to play with like thread per core configs where stuff has fallen over because we haven't given enough Kubernetes CPU resources, for example, to a particular pod. But in the end, what we like to see is all of that stuff configurable with environment variables, right? So, and generally speaking, so in the way we've done it, so we have our own custom operator, and the way we've done it is our Cassandra resource or our DSC resource. We actually have 2 different custom resources. There's basically a configuration dictionary in that kind, and we can go through and specify any of those parameters, and those will just get translated into environment variables. And then we have an entry point script that when those processes start up, will go and dynamically generate the Cassandra YAMLs or whatever they happen to be in like an init container, and then start that process up. So anyway, that's a roundabout way of saying, I kind of, when I actually deploy these things, they initially are very sort of pared down. And then if I want to, I can just update that config, and then, updating the Cassandra object will cause the pods to do a rolling restart and apply the new configs.
Okay.
Hopefully that wasn't too long-winded, sorry.
No, that's great. So do you, for your developers though, and people writing the microservices, are they always talking to a cluster inside your environment, or do they ever run it locally and they have even a further pared down? Or is it always like, okay, we're gonna provision a 3-node cluster for development, and we'll just talk to that and not worry about running this locally?
Sorry, when you say local, do you mean like on the same workstation where they're doing their development work?
Yeah.
Like in a mini cube or something?
Yeah.
No, traditionally not. Traditionally we provide basically a database as a service platform for them. So they'll just come to our internal cloud, hit new Cassandra cluster, and it'll go and spin up, and everything we do is on-prem effectively. So it'll go into one of our data centers and in one of our Kubernetes clusters and spin up a 3-node Cassandra cluster for them in its own private namespace. And then we'll just provide them the connection endpoints, and they can connect to it. So there's no real need for them to spin anything up locally. And to be honest with you, we found that, and again, this is in our own experience, but developers tend not to want to do anything Minikube or Kubernetes related at all. They just want that sort of abstracted to them, right?
Sure.
To be honest with you, they just want a database endpoint. They don't care where it's actually running.
Yeah, that makes sense. I'm curious, when you have in that model of deployment, are you using any sort of ingress? How can their workstation route to their database?
Yeah. So a few things. Yeah, it's so the first thing to understand is that we basically use a flat network. So there's no overlays going on at all within our entire studio, which means that, and second thing is we basically use Calico as our CNI, right? So what that amounts to is that any pod running in any Kubernetes cluster can be routed to from any workstation. So any developer can basically route to that pod. So the question then turns not to routability, but to discoverability. And so the question is, okay, how do we expose that pod and how do we make it, dynamically discoverable? So there's a couple things. We basically rely on DNS for discovery. So every pod. So here's something interesting. So in our operator, what we do is we scale up the number of services for the number of pods there are in that stateful set. So if we're spinning up a 3-node Cassandra cluster, we will actually also spin up 3 services, and we'll front each of those Cassandra nodes with its own dedicated service so that we can have direct routability to each of those pods. And because it's a stateful set, those identities stay the same. So if I'm always hitting service A, I'll always hit pod A, right? Then the second thing we do is we actually create DNS records for each of those services. And so we basically will go back and provide the developers, here are 3 DNS records, 1 for each node. And the pods may restart, but the services will still route to those backing pods. And it'll all be static. By the way, our services are also, we use Calico, so the service IPs themselves are routable as well.
Do you have a service that represents a data center, or do you just use those services for the particular pods as like the contact points and call it done?
No, the IPs are all just directly to services and backing pods.
Fascinating. And so if you have a flat network, any pod, you can run multi-DC pretty easily then, multi-region. Yeah. It's just a flat network. That's great. Yeah. Oh, man.
Yeah, I think there's one of the topics, like not last year or the year before, where I had somebody from, it was at Accelerate, where maybe it was, I don't remember what, but basically they had done similarly, they had exposed each node with its own service. I think there was some, maybe I talked to the speaker afterward, basically it also gives the token awareness to the clients, right? Like you have access to all of the different nodes, which we won't get that if everything's behind like an LD. Right?
Yeah, that was kind of a primary motivation for us, things like token awareness, right? So we want smart drivers to be routing their write requests right directly to the pod. We don't want them to go through a load balancer that's then going to be an extra hop or something like that. Where it does get a little tricky, and this might be sort of TMI, but in things like Azure, where everything comes in through a load balancer. So creating that extra service for every pod, you actually have to create a load balancer type of service, which actually then creates a load balancer rule in Azure. And then you actually run into hard limits as far as how many rules can be created in each load balancer. And we've run into issues there or whatever, but we'll just scale up a new AKS cluster if we run into that limit. But you are still paying the overhead of that rule. There's a cost associated with that.
Would a headless service work for you at all, where it returns each of the pod IPs, and then your drivers can still be smart?
Yes and no. So we started that route, and what that requires, and so if we're limiting the discussion here to Cassandra, yep. It kind of works, but our use case goes beyond Cassandra. So we have like 15 different database types that we support, but the trick is the driver, the driver has to be smart enough to understand those topology changes, right? So if Cassandra node C goes down and gets a new IP address, comes back up, the client has to be able to reconnect. And like I said, Cassandra drivers are generally pretty smart, so it's not that big of a deal. But things like Elasticsearch we've had issues with. And so what we do is, that's why we want those static IPs of a service so that those things don't change. But even with Cassandra, there is still there is still a problematic scenario when all 3 of the nodes go down at the same time. So let's say we restart all 3 nodes and the whole thing goes out of whack. Then we actually have to balance the microservice in order for it to basically force it to do another DNS lookup and go get the correct endpoints.
We actually hit that this past week in some of our testing, and we're looking. I don't know if I think there's an issue out about this around having a way to tell having a way to tell various services, hey, you probably want to pull from DNS again to like there are new IPs. You should probably go talk to that wherever the Kubernetes service, which ultimately ends up being DNS or what have you. But that's a fascinating point. To the
Yeah, I don't know who's designing the drivers. I'll say the Couchbase driver is actually pretty nice. There's like a new flag that they introduced called like force DNS lookup on reconnect or something along those lines. So might be something to steal from.
Yeah. So it sounds like one of the reasons that you went with the service per pod is for those fixed IPs, because stateful sets don't give you that. They give you fixed names, but they don't give you fixed IPs. I've seen some people that are messing around with like sidecars doing things with Envoy, where they would have they'd have an IP address that's fixed that Envoy knows about, and then it talks to the pod on the loopback, which was kind of fascinating. It seemed like a lot of work, but the end goal of a reliable address was interesting. I'm curious. Yeah. This leads to an ask, and there's some conversation right now on what we can do with the Cassandra project to make it more Kubernetes friendly. So I personally opened a CEP around using a different form of identity, because right now identity is the IP address.
Yeah.
Whether that be a host name, which with stateful sets makes sense, whether we go all in on host IDs, which stick as long as you have the same data volume. I think there's a bigger conversation to have there, but that's the tip of the iceberg. And maybe that's a call to action that we have is it would be nice to start to develop a list of things that we could do to make Cassandra a bit more Kubernetes friendly.
Yeah, I'll say from my own experience, I'm sorry if I cut you off, but so that's an interesting one is the IP address, and doing things like playing with like Bootstrap, whether you put it in a Bootstrap mode or not or whatever, when you bring the node back up, you can kind of get away with things. But the problem that I have is with the way that token ranges are basically associated with IP addresses. And specifically, if I want to do a blue-green migration where I take an entire Kubernetes cluster and I move it from one take an entire Cassandra cluster and I move it from one Kubernetes to another, like for a disaster recovery scenario or whatever it happens to be, when those persistent volumes come back up and they read up, hey, this token range is assigned to IP address 1.2.3.4, it causes it. It's a problem unless I basically stream across the data using, like some SS table loader or something like that.
Yeah, I mean, the whole token range and how the data is partitioned. I think like look at like Couchbase, for example, how they manage the V buckets, right? Those V buckets can be moved around, and they can the one V bucket that's getting hit a lot can scale, whereas another V bucket that's not getting as much hits can just sit on one node. Right. And that's the type of stuff that people want, right? I'm not saying it's there now, because it's when you tell people about this partitioning and like why you can't have wide partition. So that's a whole different ball game about how to make Cassandra more user friendly. Yeah. But ultimately, you're asking about a developer, right? Or the complainer, right? There's the complainers and then there's the committers, right? So the complainers are always like, why the fuck is this so hard? Excuse my language. Why is it so hard? And you were asking, what does a developer want, right? So there's at least 3 scenarios I've seen, different scenarios, right? There's an analytics scenario, there's like a transactional application scenario, and then there's one which is more like data, I guess data science-y, but same thing, analytics. And only the developers that are doing kind of I'm making an app, right? And only a specific group of the developers, maybe in the integration and the testing, they'll need something where they're like, I want to bring it up all on one Kubernetes on my Minikube, and they're very specific. They want to have like 64 gigs of RAM on their computer, and that's what they want to do. But most people, like Umair said, is give me a place to deploy code and have this work for me. That's what I want. I don't really care about the engine behind it. I just want it to work. And on the analytics side and the data science side, I mean, apart from people using like, Jupyter Hub with like Livy, talking to Spark, talking to whatever, even then, why would they set that up locally? So ultimately, it's like people that are trying to make apps, they want an AWS Dynamo or Cosmos, Azure Cosmos experience. But if they're doing Kubernetes locally, that's a really small group of people that are going to be doing that. Like people that are either people like Umair, yourself, maybe myself, that really want to get into the nitty-gritties of like making a platform, right? Designing and architecting a large-scale platform. The developer probably doesn't give a shit about this stuff.
Yeah, and frankly, when trying to run a database in Minikube, it becomes even more difficult when you start talking about like persistent volumes and having to think about storage classes and what are those going to map to in a Minikube. It's like, if I'm using Minikube just to have like a rapid application development environment, that's not it. Like if you're trying to figure out how to deploy Cassandra in Minikube, like you're going to spend longer setting that up than anything else.
I guess a natural follow-up question at this point is, for developers, so it sounds like the people that will be running it locally, or either with a local Kubernetes or with their own Kubernetes cluster, are more of the platform designers, right? The platform
architects.
Yeah.
I mean, at a slightly higher level, right? Portfolios of applications.
So if we're talking about developers, is it just assumed that someone else has already set this up somewhere, and they just need to be able to know how to connect to the interfaces and call it done?
I mean, unless they're kind of really a bootstrapped startup, no pun intended. I mean, honestly, like I don't see. And even like I interview people all the time. There's always those new fresh folks like, I'm going to make an operating system. Like those type of people will want to do this,
Yeah.
Yeah, no, I agree 100%. And the thing is, even if in that startup world, it's their data engineer hat that they're wearing. It's not their developer hat that they're wearing when they're setting this up.
Yeah, but mind you, I'm not talking about the smart startups. I'm talking about the guys that want to make everything. They want to reinvent every wheel possible, right? Those are the people that will probably be like, oh, I'm going to do everything on my one computer and then I'm going to scale it out. If you're smart about it, honestly, like you will put on EKS and then you'll run Helm chart, right? Done. You'll do it all on there, or you'll go to DigitalOcean because it's much easier to do a Kubernetes cluster on DigitalOcean than it is on anything else. And then you're going to say run Helm chart. Like that's kind of what I think about. Like we use DigitalOcean for all of our experiments.
So that's a great point. And so one of the things that we're looking at, so milestone 1 in that roadmap that I'd like to see published today is about getting our 1.0 GA. But milestone 2 is this distribution build out, which is very much, this is how you run it on Kubernetes X, whether that be on a cloud provider, whether it be on-prem with like OpenShift or what have you. Like this is step by step. Maybe there's a component inside of that particular environment that makes sense. Maybe they have their own ingress, right? Or if you're in a cloud, you're talking about load balancers attached to services instead of there are many ways to do these things, right? If you're on GCP, you probably don't want to use S3 for your backups, right?
Exactly.
So that's one of the next milestones, is to build out what that looks like. And so you make an interesting point, Raul, and I was actually just listening to the GCP podcast yesterday where they were talking about the DigitalOcean platform as a service for Kubernetes. So that's an interesting data point to take into account.
It's super easy.
So for developers,
like it is
we need to have like templates or something where you just click a button that says, hey, I want Cassandra on EKS, or I want Cassandra on DigitalOcean, and it runs and it comes back with a username, a password, and a endpoint? Is that what you think that should look like? I'm curious.
I'm bringing up the Jupyter Lab one. I was literally looking at it earlier. The 0 to here. I'll send the link right now. This was well received, right? So that it got really good traction. So basically, you go to installing Jupyter Hub, and it has, well, first it's set up Kubernetes, right? It tells you how to set up Kubernetes. We don't necessarily need to know how to set up Helm, but it has it for Google, AKS, AWS, OpenShift, IBM, DigitalOcean, and OVH. I don't know who the fuck those guys are, but, and then it has with auto scaling, right? And it says literally, this is how you do it on Google. And it's mostly the same content, but very specific screenshots and copy and paste for that particular cloud provider, right? So then you go to setting up Jupyter Hub, and it's again, copy and paste. Now, what you just described is like 2 orders of magnitude better than that. Okay, but that alone, just how to do it, is good enough for people.
Okay. Yeah. So this is an interesting conversation, because I remember, like, I still write code some days, and like, do I want to run a database locally, or do I just want to run my app, iterate quickly on writing that business logic? And I mean, yeah, I mean, that makes a lot more sense.
But seriously, if you're doing some sort of kind of short experiment, Docker Compose is more than good enough if you want to bring up 2 or 3 things.
That's fair.
It's just, how do you go from Docker Compose to Kubernetes? That's where kind of people get hung up. But, you know, generally I've seen people have a Docker Compose for local development, right? And then they have all of their Kubernetes configurations in the same repository, but that's what then gets and pushed out to, you know, via CI/CD.
Right. Great. That's a lot to chew through here, man. I really appreciate the feedback from you and Umair.
Yeah.
So
sure.
just to recap, we got a couple of minutes left. CAS operator release looks like that's happening today. There's a couple of GitHub Action stuff that's getting figured out right now that didn't run quite right on the push of the tag. Cassandra 1.0 sneak peek. It's launching tomorrow. Is the goal there. So really great milestones for these projects, where we're seeing it deployed in production with multiple users now, even in multi-region environments for CAS operator. So it's pretty fantastic. I believe that these calls are every 2 weeks. I'll double check. But thanks so much for attending. Really great feedback session. I think as a follow-up, I'm going to starting a list of things that how Cassandra can grow to be a little bit more cloud native with regards to Kubernetes. I'd love to send that out. Maybe I'll ping y'all on the ASF Slack as that list starts to take shape and solicit some feedback there. Because I know that as 4.0 is getting closer and closer to release, things like that are more apt to get worked on here in the nearer term. So I want to be ready and have some items in the hopper for that.
Yeah, I mean, I don't anticipate auto magic partitioning, right? Until like Cassandra 6, maybe Cassandra 5, but it's good to hope, right? It's good to put the ideas out there.
Cassandra
Yeah,
X.
definitely.
Yeah.
There are,
Awesome.
I mean, there's all sorts of priorities, right? What goes into the next major versus what's possible in the interim. So, but yeah, great to put that out there. Awesome. I'm going to stop the recording now.